Hi, this will be the final lecture that I do, and I'm going to attempt to show you a number of things that I think you'll find interesting and hopefully will make the material in Chapter 11 more meaningful. Specifically, I'm going to be looking at a different database management system. We're going to look at SQL Server. And then when I've shown you some of the features of SQL Server that make it interesting and unique and different from Microsoft Access, then we're going to switch over and take a look at a program development environment that I work with, and one in which I created a custom program front end to interact with SQL Server. So this allows me to create programs that are customized to the needs of users and in a very strict way control what the users can access within the database. So we'll take a look at that and discuss some programming language concepts ever so briefly, but these are concepts that you will learn more about in the next class that you take, the one that's being taught by Professor Hilbert. And when we're finished taking a look at the program development environment and the custom program that I've written, then we're going to switch over to Microsoft Access one last time, and I'm going to show you how Microsoft Access can be used to connect to other databases. And specifically, I'll make a connection from Microsoft Access to SQL Server, and we'll be able to use Access as a front end to SQL Server. So again, some very interesting things, and hopefully this complements the material that's included in Chapter 11 of the book. All right, so I'm going to start out with a diagram here, and I believe I showed this diagram early on in the semester, and at that point may not have been all that meaningful. So this is a web page, and it is kind of a schematic of a database environment, and a lot of these things you're going to see here in just a moment. So for instance, one way that I might, here's the database here in the back end, here's the stored data, okay? And so how do we get to the data? How do we, make queries? How do we read and write to the actual data store? Well, there's a couple of ways. One, we could use the database through a database management system console, which I will demonstrate, and this is really what we did in Microsoft Access as well. But as an interactive user, if I want to use the database, I would have to interact with the database management system. And the first thing I'm apt to see is some level of security. Now, we didn't look at security in Microsoft Access, and it is possible to put a minimal amount of security on an Access database file, but when we look at SQL Server here in a moment, it's going to be very obvious that this is a database management system that's designed to be used by multiple users, not just a single user from a computer desktop, and therefore you're immediately going to see the effect of an interactive user encountering security. And once you make it through that security layer, then you have access to a number of console features, and we'll take a look at those again in SQL Server. You've seen many of these same things in Microsoft Access, though, and as I show you some of the the features that are available through the management console in SQL Server, you're you're going to say, oh, this looks a lot like Access, and in fact it is. The database management system, whether Microsoft Access or SQL Server, will have a component called a database engine, and this is the part of the database management system that takes the query request, processes the SQL, and communicates onto the operating system how it needs to access the data. So the query will be interpreted, the database management system will then ask the operating system to do the disk I/O and either write records or return records that have been previously written onto the disk. That's one way that we can interact with a database. A second way is through a program front end, and we're going to look at really two examples of this. One with a custom program front end that I've written, and then secondly we're going to use Microsoft Access to do this same kind of thing. And what we'll find out is that the database management system has a program interface, sometimes called middleware, and there are a variety of different middleware technologies that exist and can be accessed. I'll be using, with the custom program front end, OLEDB, and with Access, ODBC. Okay, so what is that? OLEDB is a proprietary Microsoft middleware, again software that allows a program to interface with the database management system, and it is really the preferred solution if I'm developing a custom front end using other Microsoft technology, which I will be. I'll be using a programming language called C#, and so I get my best performance if I use OLEDB under those circumstances. There's also a generic industry-wide standard called ODBC, Open Database Connectivity, and it can be used with just about any technology, whether it's Microsoft or Oracle or whatever, whoever the manufacturer may be. So this is an generic industry standard middleware that I can use as well. So if I'm developing a custom front end, again using Microsoft products like C#, I'll tend to use their proprietary middleware because I get better performance, have more functionality. The ODBC is technology is good because it's generic. I can make any kind of programming language interface with my database, but it does have it has fewer functions, and it doesn't run quite as efficiently as some of the optimized middleware products. So in any case, if I'm writing a program, I'm going to have to deal with this middleware. I'm going to have to get my program front end to talk to the database, and I'll point that out whenever the time is right. So what are we going to do here in a nutshell? Well, we're going to access some data in a database. Specifically, the data is data in a SQL Server database, and we will be accessing it interactively in a way that you're already familiar with. Starting out, going through the management console in SQL Server, and then once I've done that, we'll look at how that same data can be accessed a couple of different ways, either with a custom program front end or by using Microsoft Access. Okay, so close up this diagram and let's take a look at SQL Server. So the management tool that I have in SQL Server is called Management Studio, and I already have it, installed on this computer, and I have a shortcut here on my quick launch toolbar. So as soon as I start up the management console, I immediately encounter security, and it says, how do you want to gain access to this database management system? And I have two ways. I can either authenticate with my Windows login, or I can authenticate using an account set up within SQL Server. And since I'm doing this on my laptop and I'm not really connected to a Windows domain, I'm going to use the SQL Server authentication, and I'm going to log in as a SQL Server object called SA, or System Administrator. And when I do, I have to give it my username, and I also have to give it a password, and my password happens to be uppercase S, uppercase Q, uppercase L, 2012, and @. So it's a fairly hard password in that it uses a combination of alphabetic, numeric, and special characters, and I also elevate some of the characters to uppercase. So I'll be logging in as System Administrator, and when I do, I'm going to have all the capability, the permissions that are possible in using the database management system. So this wouldn't necessarily be the way I would want everybody to log in. In fact, I wouldn't want everybody to log in as System Administrator. In a moment, I'll show you what other options are, but for now, just realize that I am logging in with godlike privileges, and so I'll be able to do anything I want to here. The server name is Big Mac, okay, and again, I have this server installed on my computer here, which is a MacBook Pro that's been partitioned for Windows and has a big screen and everything. So when I had to name the computer at that point in the process of configuring the operating system, I called it Big Mac, but that's where Big Mac's coming in. It has nothing to do with McDonald's or anything. And if I say connect, immediately the Object Explorer object bar here becomes active, and at the very top I see a reference to Big Mac, which is SQL Server installed on this machine, and all the various features of SQL Server as it relates to this machine. Now, if I were on a network, and again, I'm working from a platform that's been set up for development purposes, but if I were working from a network, I could install the console, and I could conceivably register to many different SQL Server database management systems. So it might be that in your corporate setting there are multiple servers, and if that's the case, you can, through this console, access multiple servers. And it gets more interesting than that. In order to use those servers, obviously you have to have the correct security credentials, but assuming you have all that, it is possible then to take data from multiple databases and merge it into data sets on your local computer, and then generate reports and execute queries and do analysis and all kinds of things. So this is the main tool that I routinely use with SQL Server, and there are lots and lots of features that I simply know about but have never used. A lot of the data analysis tools is pretty rich with with ability to you know, use tools to analyze the data. All right, so what I want to do real quickly is just peek around in some of these folders. So if I expand the database folder, I see there are a number of databases. I created this one, I created this one, and I'm going to use this one because it's a familiar database for you. So we've worked with the HR SQL database. This is a SQL Server version of that. So I took that logical design and built a database in SQL Server. And if I expand this server icon, I see a number of different functions and features that I have available to work with, specifically with the HR SQL2 database. One would be database diagrams, and if I double click on that, this should look familiar. You know, I have the 4 tables that we have seen before, and it stores much of the same data. Now some of these columns are different because I'm doing some things in SQL Server that I cannot do in Access, and so I have changed, you know, the design of the table somewhat, but still by and large it's you know, very much like the database you're familiar with. You'll notice that there are relationships among the tables. The key represents the one side of the relationship, and the chain, or whatever that is, I don't think it's an infinity symbol, but whatever that thing is, represents the many side of the relationship. And let's see what else we have. We have tables, okay, so I can expand the tables feature, and I have a couple of different ways that I can access the table. So if I go to the employee table and I right click, if I choose design, then this is like design view in Microsoft Access. I'm going to be able to make structural changes to the database table. On the other hand, if I choose select top 1000 rows, it'll open the database and allow me to see the data in a read-only view. I won't be able to make any changes, but I can at least, it's like data sheet view in Microsoft Access, except I can't make any changes. I can't write to the database. I can certainly look and see what's stored in it though. So that's a possibility. Another way that I can access this data would be to edit top, I don't know how many rows that was, but that allows me to get a listing of the first few rows in the database table, and then I can extend beyond that if I need to. But here I can actually change things, okay? And in fact, I think I will. I'm going to change this field, which is the employee audit date field. And I'm going to change this for a reason, because we're going to do something with it here in a moment. I'm going to change that from its current value to, if I can see inside of this, I may have to expand that column a little bit. Let me expand the column. Okay, so here we are. For Chuck Kuntz, this is record, the last record, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is record 9, and I'm going to change the 2014 to 2012, and I'm going to do the same thing for Charles Kuntz for the first record. Do the exact same thing, change that from 2014 to 2012, and again that'll mean something here in a moment. So right now I've opened this table up, and I've been able to actually edit or write to the database, and I'm going to close it up. and nose around here just a little bit, just point out a few things. Under programmability, we're going to look at today stored procedures. I've written a number of stored procedures, over the time period that I have worked with this database. I didn't do all this morning, obviously. And we'll take a look at some program code. In fact, let's just go ahead and jump right into that. There is an example down here called Secrete Cursor example. So I did some database consulting work for the government of Iraq, and I taught some classes for Tikrit University in Iraq, which sadly enough has been now overrun and nearly destroyed by ISIS. I still have some colleagues in the area, and they've sent me pictures, and it's incredible to think after doing consulting work and helping the university for 3 years, in a matter of weeks or a few short months, much of what we accomplished has been destroyed. Buildings burned, computer labs wrecked, and it's just sickening. But I won't go off on that tangent, but this was a stored procedure that I used when I was teaching a class for them. And if I choose to modify the stored procedure, I can see the program code, and now we're looking at something a lot different than what you've seen before, but it is similar to what you're going to see next semester when you look at a programming language called JavaScript. Now, what we're actually looking at is a scripting language in SQL Server called TSQL, as in Transact SQL. And it allows me to integrate a declarative language, SQL, with an imperative language, and really put SQL on steroids. So what does all that mean? That means that I can create references to memory locations and store data. These are called variables, and you'll know what variables are soon enough next semester. But I declare a number of variables to store data as it's being processed, and then I have the ability by using this imperative language component to perform some rather involved arithmetic operations, and to design my SQL so that it can execute on some occasions and not execute on others. So I can build decision logic into this, and if conditions are such, it will execute, and if conditions are not such, it won't execute. And here's an example where that's happening right there. So I have an if statement, and if this expression up here where it says at PMO less than at diff month, then I would execute everything that you see from the begin statement through the end statement. And what I would be executing would be 1, 2, 3, 4, 5 SQL statements in sequence. Okay. Now, I'm not expecting you to understand any of these details. This is really intended to be kind of a example from 20,000 feet. But what I would like for you to come out of here knowing is that with declarative languages like SQL, we have a finite set of operations that can be performed, like inner joins and outer joins and products and things like that. And when you provide the query instructions to the database management system, you don't tell the database management system how you want it to perform the task. You just tell it by way of SQL operations what you want done, and you leave it to the underlying system to determine how it's going to be done. In an imperative programming language, you have to write the instructions to describe how the process is to be performed. And imperative programming languages operate under three fundamental flow of control structures. Statements that you use in describing how the process should be performed can be executed one after the other, which is known as sequence. They can be executed conditionally, as is the case right here. If the condition occurs, then execute the statement, otherwise ignore it. And you also have the ability to design these flow of control structures that will allow certain statements to execute over and over again. And in fact, I have such a structure in place here. I have what's called a loop or a while loop. So, if you're studying informatics, again, you're never going to really be doing programming, but you ought to be familiar, at least to the extent of knowing that there are two main classes of languages, declarative and imperative languages. You've worked some with a declarative language, but there's this other class of languages, TSQL would fall into that category, as well as C#, which I'll demonstrate here shortly, as well as JavaScript and Java and a number of languages like that. And in those languages, you're going to see loop structures, and you're going to see decision structures. And so next semester, when you work a little bit with web pages and JavaScript, you can reflect back on this lecture and say, we were doing something similar in the context of database programming. He was using a different language that was specific to SQL Server, but nevertheless, the things that I'm doing, creating variables, designing loops, designing decision structures, all of that is just very typical of programming in an imperative programming language. Okay, so what does this do? Long and the short of it is this. I'm not going to do the complete code analysis, but I can call this script up. There's a way that I can invoke it, and the script is called a stored procedure. And when I do, I can pass it some data, okay? And I've got it designed actually so that I pass it two chunks of data, two data items. One, I tell it who is running the script, so the person who's running the script would type in their name. And then also, they're to provide a integer value, a number, a whole number, that represents the number of months that they want to use as a threshold value in checking to see whether payroll should be updated or not. So basically, if I type in 6, then that means that when the script runs, it will look in the employee table, and if the employee's pay has not been updated, has not been adjusted, their base salary hasn't been adjusted in the last 6 months, then it will go ahead and adjust it. So they'll get a pay raise. But the program's also designed so that it doesn't give everybody a pay raise every time the scripts run. It's just that they will get a pay raise if the last time they received a pay raise exceeds this numeric value. So I'll show you that here shortly. Okay, it's going to be using the employee table, and whenever I change those two records, I changed the date field, and what I did was I kind of tampered with the data, cooked the books a little bit, and made it so that when I run the stored procedure, I can anticipate 2 of the records then will get processed. Okay, well that's the idea of a stored procedure. So I can think through some really detailed logic, like in this case, how would I, have the program go into certain tables and calculate a pay raise under some circumstances and not calculate it under other circumstances. That goes beyond just basic SQL. Again, it requires that I use a more complete imperative language. The other thing I would tell you about stored procedures here, two things. Number one, they are compiled. So if I write a stored procedure, I can compile it or translate this English-like looking language into a binary format so that in the future, anytime that stored procedure gets called up, it's in a form that is immediately ready to execute. So it will process very, very quickly on the server. It's compiled code. The other thing that I can tell you is that these stored procedures then are objects within the database, and I can put security on it. I can control which users have access to the stored procedures and which ones don't. And that security would apply as the user interacts through the console, and it also applies when a user runs a custom program front end. So we'll see here later on that when we look at this C# program, this custom program front end that I've written, when we look at it, you'll see that there's something called a connection string, and in that connection string I have to include a username and password. And if that username has not been set up to work with this stored procedure, then whoever is running the program front end won't be able to execute this program, and consequently won't be able to update the pay. Okay, so I'm going to close that up, and well, let's just try running this stored procedure real quick. Okay, I'm going to run it from the console, and so if I find the stored procedure in the object bar and right click and execute, I can execute it from the console. Again, I can also do this from a custom program front end, and doing it from a custom program front end is really the nicer way and the way it would normally be done. But I can run it from the console, and if I have permissions, and sometimes this is very useful in developing software because it's very convenient to test it and see whether it's working right before it's actually made public. So I'm going to go ahead and refer to myself here as Chuck K. I'll do it that way. Alright, so that's the person running the script, and then we're going to go back 3 months, let's say. So if someone hasn't had a pay raise in 3 months, then it should process them, and if I've cooked the books the way I think I have, that means that I'll be getting a pay raise, and the other person that has a name similar to me will get a pay raise. Okay, sounds kind of suspicious, but nevertheless, we'll run the program, and it comes back. There's some messages here that I've put in for more or less for debug purposes. So in class I would have gone through an analysis of why this code is executing the way it is. The program, when it runs, gives me a diagnostic. It says return val. This is the output from a system variable, and a return val of 0 means that the script executed. So 0 is a good thing in this context. And now if we go back to the employee table and I right click and I select top 1000 rows and look in here, we'll see that there is, looking at the system clock here, this is October 2nd at 8:07 if you look down the bottom right corner of my screen. And as we look at Chuck Kuntz, he got updated October 2nd at 8:06 a minute ago. And also this other suspicious character got updated at the same time. And so they got a pay raise, and no one else did. Okay, so the script was able to identify those two people that I had cooked the books for, and gave them a pay raise and did not give anybody else a pay raise. So it made a decision, you know, is the time frame sufficient to, you know, give a pay raise? And those two records were examples of where the time frame had you know, been sufficient to allow the program to do the pay raise. Okay, so hopefully, you know, I've been able to avoid enough detail that you just, you know, your eyeballs are not popping out of your head at this point. But at the same time, hopefully you're getting the sense that this is what programmers do. They have to write this very exact code, and yes, you know a little bit about SQL, but there's also another programming language, or another type of programming language, an imperative type programming language that allows you to do even more than what we were able to do with SQL. Now I want to try to you know, wrap this part of it up very quickly here. I don't want to leave you with the impression that SQL is, you know, insufficient and lacking, and, you know, you've just spent a lot of time on something that's not useful. That's totally not the point. SQL is a very specialized language. It's a language that's designed to allow you to manipulate these tabular structures and exchange data. TSQL, JavaScript, some of these other languages have their own special purposes, in that they allow you to make logical decisions, and they allow you to iterate, and they allow you to do more complex calculations. And with TSQL, you get the best of both worlds, because you're able to integrate the imperative programming language with the declarative programming language. So it's really you know, ideal for working with databases, doing database programming, because it provides you the best features of both type languages. All right, so I think that's sufficient here. And, you know, we could look at some other things. I could show you, you know, some things about security, one of the things I will, I guess, just show you real briefly is that in SQL Server we have the ability within the database management system to create accounts. There are some accounts that are created for you automatically, and then you have the ability to create new user accounts, and you have the ability to assign roles and permissions. Okay, so you can create a user, give the user a username and password, and control which objects they have access to and what kind of access they have to those objects. So you have a lot of security. This is the key point. You have a lot of security that you can build into the database management system itself. And then you also have a certain level of security that is provided through the login and through the operating system. So with SQL Server, basically it's a two-layer security. You have to be able to authenticate either as a SQL Server user or as a recognized privileged Windows user. But when you authenticate, that just opens the door for you. You still have to have access to the various objects to include stored procedures and tables and a variety of other things. So we can really clamp down the security in the database management system like this. You have lots more security capability with SQL Server than you do with Microsoft Access. And that's a good thing, because this is the kind of database management system that's designed to support many users, and it's also designed to support concurrent users. All right, so I'm going to wrap it up with the part of the video here for Management Studio and move into something a little bit different. Actually, I think I'll just leave this open, because I may want to come back and see something. It'll save me having to log in again. But now what I'm going to do is take a look at, the second thing I want to do is take a look at a program development environment called Visual Studio, so you can see how I can write a custom program that will interact with a database management system. And so I'm launching Visual Studio, some other software that I have installed on this computer. And this morning, before I started the lecture, I created a real simple custom interface, and I'm going to open that up now. And let's take a look at it. I'm going to run it first, and then we'll point out a few things. So if I run it, I get a form here, and I've got the option to use two additional forms. One that will execute some embedded SQL, and I'll show you what that is. And then I also have a form that will allow me to execute one of the stored procedures that I've written. So if I choose this first option, up pops a bunch of names. Where did these names come from? They came from that same SQL Server database. Okay, this is a list of employees and their dependents. And so what happens is my custom program will contain an SQL statement, and when it connects to the SQL Server database management system, it will pass that SQL statement to the database management system. The database management system will execute it through its database engine and send the result sets back to my program, where my program displays them on a screen. The other example here is where I run a stored procedure. So rather than my program providing the SQL statement, it simply connects to the database and says, hey, run one of those stored procedures that Chuck Kuntz wrote. And that stored procedure requires a data item, so I enter in 1, which represents the employee's primary key, and when I click it, I see all the dependents of Chuck Kuntz. And we'll go back and look at that stored procedure here in a moment. Okay, so again, a couple of different program features here, and let's take a look at this development environment. And you're looking at yet another imperative language called C#. And this first form, let's see, which form am I on? I'm on form 2. Okay, form 2 is useful. This is the form that when it starts up, it just immediately displays data. And if I look at the program code behind this, here's what it's doing in a nutshell. It is connecting to my SQL Server database, and I am connecting using a connection object. I'm having to tell it the name of the server. Local means the SQL Server installed on this computer. I could name it something differently if I wanted to access a SQL Server on a network. Initial catalog is the database within SQL Server. So if you recall, I had more than one database in SQL Server. Recall, there is a database called HRSQL2. There's another one called Bridge Table Example. Okay, and as I look at this. It is accessing the HRSQL2 database on this SQL Server database management system. And then I also have to log in with proper credentials. I'm logging in as SA, and I'm logging in with a password of SQL 2012 @ which is what I had mentioned previously. I have a command object that I can use. Now, I have a connection object and a command object and a data reader object, and these are all objects. If I can get back to that. These are all objects that exist in this realm. My application would be the forms and all that stuff. The objects that I'm referencing, SQL, data reader, and so forth, are all objects that are designed to interface with the database management system middleware. Okay, and I'm using the particular middleware I'm using is called OLEDB. So that's where this code resides, and so it's going to provide the objects that can interface with the database management system middleware, and that's how I'm able to communicate back and forth. I communicate back and forth through these ADO.NET objects. And again, don't get too terribly stressed over that detail, because you're never gonna go there. You're never gonna have to worry about the details unless you major in computer science. But nevertheless, that's what I'm doing. I'm creating a bunch of objects here that allow me to interact with the middleware. And you'll notice that one of those objects in its configuration is requiring an SQL statement, and that should seem like pretty familiar stuff to you, because what it's doing is an inner join between the employee table and the depend2 table, and that SQL is written the way that you've been writing SQL, with the exception of it's being written on a single line. Okay, so the program has the SQL defined, and when it runs, it's going to connect to a very specific database on a very specific server under a very specific username, and it's going to pass over this SQL, and when the SQL is executed, it is then going to begin to return these records. It's going to begin to read the result set, and here is a loop, and it is going to repeatedly take a row of data from the result set and put it in the list box, and the overall effect is that. Okay, now let's take a look at the second one. Very similar. On form 3, I have some program code up here that again is going to make that connection to the same database server, the same database on that server. This time it's a little different though, in that it's not going to pass the SQL statement to the server, but rather it's going to pass the name of the stored procedure that it wants to execute. And then once it executes that stored procedure, again, it drops into a loop and prints everything out on the list box. But there's a stored procedure called proc HR frontend op3, and if I go back over here and look in the programmability folder, I see there's a proc HR frontend op3 stored procedure. That's the stored procedure that's being called up, and if I look at what's there, it's an SQL statement, and that SQL statement is requiring one chunk of data, and that's going to be the data that the user inputs right here. There we are. Okay, so custom program front end, and I realized that wasn't anything all that fancy, but I just wanted to put together something kind of, you know, quick and dirty here so you could get a sense that I can write these program scripts, put them on the server, I can manage them on the server, I can test them on the server, I can safeguard them on the server with the server security, and I can also write a program front end that can interact with that database server, and it can either pass it SQL and have it execute the SQL and then it receives the result set, or the program can be written in such a way that if the stored procedure exists, it can call up it can ask for that a stored procedure be run, the stored procedure can be run, and it will run faster because it's been compiled. It's actually quicker than, you know, to call up a stored procedure is actually quicker. Will execute faster, and you know, it can take the result set from the stored procedure. But in either case, in order to make any of that happen, we have to provide the proper credentials through the connection string. Okay, so pretty fascinating stuff. And what I'm showing you here in a Windows desktop, the way this is done in web forms is essentially the same way. So you know, it would be just another step to show you how to do this with a web front end. But certainly I could do everything that I'm doing here in a web front end, and, you know, access the access the SQL Server database from on top of Mount Fuji if I wanted to. Okay, that is the second part of what I wanted to show you. So let me close up the program now, and I'm going to leave SQL Server up and going, and I have closed up Visual Studio, and now what I want to do is launch Microsoft Access. Now I'm going to create a new database in Access, so blank database, and I'm going to call this dud or something like that. All right, there. All right, so I created a database, and in Microsoft Access it's trying to give me a new table. I'm going to close that up. So there are really very few objects, no tables, no queries, no forms, no reports. Okay, and what I'm going to do then is I'm going to go to the external data page. So we're going to do something a little bit different. We're going to link to that same HRSQL2 database in SQL Server. Now SQL Server is running in the background. You got to understand that. And I'm going to choose from the external data page ODBC database. Remember, ODBC, Open Database Connectivity, is how I connect to the database management system through this middleware. Access can do the same thing. And I've got the option here of either importing the data, which would read the data and copy it into Access and then basically disconnect. So that would be kind of a read-only solution. I also have a possibility of linking to the data source where I can stay connected and change the data. And right now it needs to know about the data source, you know, how do you want to connect to this thing. And what I am going to do is choose a data source name, ODBC driver that I've already configured. So I don't know that it does any good to show you how to configure this ODBC driver, except to say that if I were going to do it, I would choose Visual Studio and begin to go through the wizard to create the program code necessary to make this ODBC connection, and then it would store it in a file. Well, I went ahead and created that file previously, and I created it on my desktop, and I put it in a folder called ODBC, and I named the file ConnectEX1. So rather than having to configure that file to create the ODBC connection, I'm going to use a file that I created previously going through this entire process, and I'm going to say then OK. It wants to know, because I've configured this thing to connect to that HRSQL2 database, it wants to know, who do you want to log in as, and it's suggesting SA because I had tested this previously. And so I'm going to log in with my password of uppercase SQL 2012 @ and tell it OK. And when I do, it shows me the different database objects that I have access to include these tables. And I'm going to highlight all these tables and say OK. And it then creates a connection to these tables, and if I were to open the employee table with a double click, you'll see some of the familiar records. And in fact, I'm going to put in a new record. So I'll put in this guy will have a job type of 1, and last name will be Howard. First name will be Mo, and 222009999, and what is this? Date of birth 1/20/1900, and what its column is date of employment 1/1/2000. Okay, so the guy was only 100 years old when we employed him, and we gave him a starting salary of $30,000. And what is this field? That is the audit date field, and I'm just going to leave it blank. And this is the audit name field. That's the field that gets populated from that stored procedure. And then there's another field, a date stamp field, that's used for doing something that's really beyond what I'm covering in this class. But SQL Server has the ability to support multiple users concurrently, and therefore if you have two people that are in contention for the same data and are trying to change it, you have to provide what's called concurrency control, so that the users don't change the data without the other person knowing. And I have this table set up so that it can support concurrency control by using a timestamp, and I think for our purposes it's sufficient to say that some of the processing becomes more and more complicated in a multi-user environment, and one of the things that become necessary to do is to manage the order in which the users are able to write to the database tables, and that is a whole different area known as concurrency control. And there's a couple of ways that concurrency control can be done. It can be done through either an optimistic concurrency control technique or a pessimistic concurrency control technique, and I have this set up using a timestamp to implement optimistic concurrency control. So that was a lot of, needless babble maybe, but on the other hand, if the idea of controlling how users read and write to database tables in a multi-user environment appeals to you, the topic is concurrency control, and that is something that certainly you could go to Wikipedia and do a quick read and at least be knowledgeable of that concept. But I have the ability to do that and control that through my program front end if I'm using concurrency control, optimistic concurrency control. So I can do it from the program front end. If I'm doing optimistic concurrency control, I can also do it from the database management system if I'm implementing pessimistic concurrency control. Okay, so I'm here in Access, and I have added a row of data, and I'm going to save, and I'm going to exit out of Access. I'm back in SQL Server. I'm going to close up the programmability folder and go to the employee folder and select the top 1,000 rows, and there at the bottom you see Mo Howard, and that record was written just a moment ago from Microsoft Access. So I could use Access as a front end to a database server, provided I have the the authority to do so. And if I use Access, although I didn't demonstrate it, I have the ability then to use all the tools in Access to include forms and reports, and so I can use this data and finesse it using some of the nicer features of Microsoft Access. So we saw how to use the report generator in Access. It would be possible to get the SQL Server data and dress it up real nice and send it to the printer, or send it to a web page. And as a matter of fact, maybe I will just do that right now. I hadn't planned to do it, but I'm going to go back to Microsoft Access, and let's generate a report from that table. So here's the data in kind of its raw form, and I'll launch Access again. I'll use the database that we already have set up here, right? And I'm going to enable content, and I'm going to create a query, and I'm going to create a real simple query. So I'll go to the create page and go into query design, and in fact I think I'll even use QBE because I'm just too lazy to write the SQL at the moment. I've been up since 3:30. Okay, so let's drag down the employee last name and the employee first name and the salary. How's that? Salary, and run the query. And there we have our employees and their salaries, and I'm going to save the query as query 1, and I'm going to close up this query window, go back over, create a report. Okay, so create a report using the report wizard. Okay, and I'll generate the report from query 1, and I'll include all the fields. This is not going to be anything fancy, okay? And just keep telling it next and next and next. let it take all these defaults. And what do you want to name your report? Query 1. Okay, that's fine. Now you realize I can go into design view and I can change the headings and I can change all this stuff, and we've seen this demonstrated previously. So I don't see any point in doing that, but what I'll do is just save the report, and now I will close up the report, and I want to generate a web page, and I have to remember how to do this. I haven't done this in a while, but I'll use the external data feature, and I believe so that's the same place that we saw, you know, the ability to connect to the database. You have a option under more to create HTML documents. My data source is going to be this report, okay? So I could, apparently, and I've not done this, link to a query, for instance, in SQL Server, and not even have that query object here on the in Microsoft Access, but I've already created the query object, so I'm going with the data source from the current database, and specify the source of the definition object. Let's see. Well, it's in a path of Chuck Kuntz documents. Okay, select the source and destination of data. Okay, I'm going to browse. I think I'm going to put this on the desktop so it's a little easier to find. In fact, I'm going to put it right there in the ODBC folder, and I'm going to call this my report, because I think this is where I specify the name of the web page. So I'm going to say okay to that. Yeah. Let me close that up. I've done this before. Sorry, I may end up having to edit this video if I don't get my act together. Select a source and destination. Specify the source of the destination object. Cancel that. I don't remember that ever being an issue. Okay, try this one more time. Append a copy of the record tables. Link to the data source by creating a linked table. Know exactly what I'm doing here wrong, I think. External data. I should be using export. Alright, so I may have to chop some of this out so you don't have to watch me botch this whole thing. And what I should be doing here is clicking on query, I think, and under export more HTML document. Yeah, okay, so I made the wrong menu selection. And so it's going to attempt to put this in the documents folder. I will choose to have it put it right on the desktop, and it wants to name it query1.html, and that's fine. And whatever the default options are fine. And I'm going to choose the Unicode UTF-8 encoding scheme. That one's a little more robust, and especially if I have any kind of graphics characters that are not standard in English character set. So if I'm, generating some text that might be in another language like Arabic, I would want to make sure that I use this. And this part just says, do you want to save these steps so that you can run this again without having to run through this wizard? And I'm going to ignore that and say close. And now if I close up this database, so sorry for messing that up, I can look on the desktop, and if I right click and open with Internet Explorer, there is the output of the data. And so where did this guy originate? It originated in a SQL Server database table. And how did I access it? I made an ODBC connection to the database server through Microsoft Access. I linked to the table. When I linked to the table, I went ahead and added a record for Mo Howard, and then I, from Microsoft Access, generated a report from that database table where I was able to list the names and the salaries. And then once the report was generated as an Access database object, I then exported that report in an HTML format, and at this point I can publish it as a web page. Okay, well, I may have to do a little editing there to make the end of this more understandable and more palatable. But this is my attempt to add a little bit more information to what was included in Chapter 11, and maybe now after seeing this demonstration, SQL makes a little more sense. You get a better understanding of the ways in which SQL can be used, and you have maybe an even bigger appreciation for the material in this course. Thank you.